Advanced manufacturing technologies. The conventional manufacturing processes involve more human intervention in the setting of tool, changing tools, measuring dimensions in between operations, etc., which are eliminated in advanced manufacturing technologies. In this section, the discussion is limited to the introduction, description, working, applications and advantages of the following. 1. CNC machines. 2. 3D printing, also called additive manufacturing, and 3. Smart manufacturing processes. 1. CNC machines. Figure 1. Block diagram of CNC machine. A computer numerically controlled machine is the one in which the operations of the machine are controlled by the numerical control system. The working of a CNC machine is explained in the block diagram. The product design is made using CAD software and fed to the numerical control system. The code, program, which instructs the machine to carry out step-by-step operations on the workpiece is written. Initially, a simulation run is done to check the correctness of the program and to visualize the shape and configuration of final product on the monitor or screen of the computer. The machine, lathe, drilling machine or milling machine, which carries out the operations on the workpiece is connected to the numerical control system by means of a servo system. This servo system, which is connected to the driving mechanism, guides the operations of the machine. Once the workpiece is fixed and necessary tools are fixed in the tool post, and the machine is given command to run, it will automatically carry out the operations till the product is finished. A feedback mechanism is arranged in the system to provide feedback on the actual process against the instructions. It detects the position of tool with respect to the workpiece, its speed, feed and depth of cut, etc. for comparing with the actual instructions. Advantages of CNC machines. 1. The machining operations are quick, accurate and noiseless. 2. The processes are carried out automatically in the sequence as per the part program. 3. The human intervention in changing the orientation of workpiece, changing the tools, speed, feed and depth of cut etc. are eliminated. The role of the operator is limited to feed the workpiece in the beginning and to remove the finished product from machine at the end. 4. Since the machining operations are accurate, close tolerances are maintained, less inspection and quality control activities and no need for further finishing. 2. 3D printing, additive manufacturing. The 3D printing process, also known as additive manufacturing, involves creating three-dimensional objects layer by layer from a digital model. The specific steps can vary depending on the type of 3D printing technology being used. Here is a general overview of the process. 1. Designing the 3D model. The process begins with creating a digital model of the object to be printed. This is typically done using computer-aided design, CAD, software. The 3D model defines the geometry and structure of the object, providing a blueprint for the 3D printer to follow. 2. Slicing the model. The digital model is sliced into thin horizontal layers using slicing software. Each layer represents a cross-section of the final object and serves as a guide for the 3D printer. 3. Setting up the 3D printer. The 3D printer is prepared for the printing process. This includes loading the printing material, filament, resin, powder, etc., into the printer, and ensuring the printer is calibrated. 4. Printing the object. The 3D printer starts building the object layer by layer. The printing material is deposited, solidified, or fused according to the specifications of each layer. Different types of 3D printing technologies use various methods for material deposition, such as extrusion, photopolymerization, or sintering. 5. Layer bonding. As each layer is deposited, it must bond with the previous layer. This is crucial for the structural integrity of the final object. Some printing technologies involve melting or fusing the material together, while others use adhesives or other bonding mechanisms. 6. Support structures, if needed. For objects with overhangs or complex geometries, support structures may be added during printing. These structures provide temporary support for overhanging features and are removed after printing. 7. Post-processing. After the printing is complete, the object may undergo post-processing to improve its appearance or functionality. This can include removing support structures, sanding, polishing, painting, or other finishing techniques. 8. Quality control. The printed object is inspected to ensure it meets the desired specifications. This may involve checking dimensions, surface quality, and overall structural integrity. 9. Final product. Once the post-processing and quality control steps are complete, the 3D printed object is ready for use or further integration into a larger assembly. Types of 3D printing technologies. There are few 3D printing technologies, each with its own specific processes. Common 3D printing methods include A. Fused deposition modeling, FDM. B. Stereolithography, SLA. C. Selective laser sintering, SLS. The choice of technology depends on factors such as material requirements, precision, and the intended application of the printed object. Figure 2. The 3D printing process and products made of 3D printing. 3. Smart manufacturing. Smart manufacturing solutions use artificial intelligence and machine learning to contextualize information and provide actionable insights, enabling you to predict machine failures to get ahead of maintenance, adjust production schedules, and avoid costly downtimes. The following are examples of smart manufacturing technologies. Machine learning, augmented reality, virtual reality, automation, robotics, hybrid manufacturing, big data analysis, cloud computing, CNC machining, design for manufacturing, IoT, Internet of Things, simulation. The technologies, when integrated with the conventional manufacturing technologies or processes, the organizations can reap the benefits of automation in the production processes, material management, quality control, maintenance and repairs of machinery, rapid prototyping, and so on. Figure 3. Assembling of car parts using robotics. Figure 4. Application of AI in analysis of data.